And then I'll start Skype, just in case there's anybody on there.
Riggs?
It's under labs, Josh, or?
Oh shoot, I can't.
Is it Riggs J3? Is that
Yeah, it's under labs.
Your first chunk.
No, leave it.
I'm gonna use Phillips.
Oh, really? He changed it? No,
So
not
you
when he
just
first
check
sent the email. He said, that's what he said to do.
Now your first is gonna be 471
Okay, yeah.
underscore
TCC.
TCC1.
I just realized I can't do this
Yeah,
now
no,
to log off.
when it first was set up, he said we could only use.
Sorry, just a second,
Riggs
guys.
J3 or whatever. That's what I used, but it stopped working like 2 days ago, so.
I'll log in myself. There we go.
And you said it's in the labs folder?
Yeah, so it should be under the labs folder. It'll say homework 4. Click on that, and there should be a Catia folder. And inside the Catia folder are all the parts that you need to
The
see it.
Catia top down?
Yeah, Catia top down.
Should we put in that about?
There's just no homework.
Yeah.
Yeah,
Labs
the
folder.
new folder that you created this week, what's the point
Why doesn't it have this? You can save as. It's so retarded.
Just open the
I know. I sent that to everyone.
Oh, okay.
Most everyone else.
That's retarded.
Okay.
Okay, I'll start a join.meet conference if you guys want to use that.
Yeah, we started it last week.
Just, yeah, you
Why don't they put freaking save as?
No.
But there's a cute
There it is.
Just go to change your options.
Oh, okay. Well, that's very
So
cool.
figure out that. You can change or you can change
Well,
the ask.
I want to be able to. Okay, how do you do that?
So go to your Firefox. Yeah, make it call.
Okay, so the code for today is 227-699-933. 227-699-933. So if there's any students at NTU who would like to hop in while we are doing this tutorial, that is the code that you can use for join.me. So I'll do some screen sharing there. So you guys, if you guys want a closer look, you can also display it here on your computers, and I'll give you guys kind of an indication on what's going on here a little bit better. So, okay, so I'm gonna hop into Catia. As soon as I get my scroll bar to work here. Okay, so while that's loading, I'll just kind of go over today's homework and give you guys a little bit of an explanation of kind of what's going on. So today we're going to cover top-down assembly. It's a little bit complex, and so I understand if you guys get a little bit frustrated at first. Just to give you guys a little confidence, I've been teaching top-down now for about 2.5 years. And I also taught the ME 172 class over the summer, and we had to go over top-down. So I have a lot of experience with troubleshooting this, so I can help you guys if you get stuck. So we're just gonna kind of download all of these parts. While they're downloading, I'm just gonna kind of go over the in-class exercise and the homework for you guys. And then we're gonna just hop into the actual parts and show you why top-down is so cool. And then I'll show you guys kind of how to set up a top-down assembly. And then I'll give you guys some time to go ahead and do the in-class exercise. So the in-class exercise today, you're going to get with your team members from your school. So the members at NTU don't need to necessarily be here today. They can do it online and watch this via YouTube if they'd like to, or they can work with their teammates here at BYU. But I've got an assembly up on Team Center Community. It's the connection rod assembly.part. The .part is an NX specific tag, so it'll be different for you guys. It should be say like a .cat product. But one team member is going to build the lower control arm, which is green. My printout here is actually black and white, so the green one should be this one right here down here on the bottom. They're all labeled right there. And then the pin. The second team member will model the upright or blue And the last team member will model the ball joint. And so for you guys, you'll probably need to model a few extra parts since it's just the 5 of you here. You can find detailed images of each of these parts on TCC. So we've got like this printout here on TCC. You can use linked or published geometry and waived published parameters from the subassembly to create your parametric parts. So for the teams that have 3 members, I will let you guys use this particular assembly that I've downloaded, but I will remove some of those parts, or you guys will remove some of those parts, and then you'll need to re-add those parts just so that you guys can get kind of familiar with how this process works. After completing all of your parts, you'll go into the subassembly, change a few parameters just to make sure that it's morphing. And I'll show you what that means in just a minute. As far as submissions for the in-class assignment, you guys are going to, each group will share a single Google document or PDF entitled lab4 underscore group name and then underscore the school that you're from. And you'll upload that to Google Docs and you'll share it with BYU 471 Fall. There are there will be 2 of these documents, one by the BYU students and one from the remote team. For you guys, since you're all here, you guys can just submit one and then each have you guys each do a different part. What you'll turn in this shared document is going to be 3 images of the assembly. One of the images will be of the skeleton, which I'll show you guys what that is in just a minute. One will be the skeleton with suspension, and the third one will be a morphed skeleton with an updated suspension. So we'll just kind of go ahead and get started on that. For the homework, you guys don't need to do number 3. We don't have the multicultural team assessment PDF up on TCC, and so from what I've been told, is that right, Jared? We're not doing number 3 then? Right. Okay. So you only need to do number 1 and number 2. Number 1 is just planning out your subassemblies. So as we go through this exercise, you'll become aware of the importance of having different subassemblies so that your team can model synchronously at the same time, but in different part files. And so you'll need to figure out how you want to break down your vehicles. And so you'll kind of create a list of subassemblies that you want for your vehicle. You will determine as a team what components of those parts will be in those subassemblies. You're going to identify the interfaces and interdependencies of these subassemblies and parts, and then you're going to create a set of assembly parameters that you will be used to constrain the assembly skeleton. So essentially what's going to happen is you're going to meet with your team as a whole. You're going to organize how you want to break the car down into subassemblies, and then as a team you're going to create the parameters and relationships for your skeleton, okay? For the master assembly file. You're going to share this list of parameters, subassemblies, and the team's parts, like what parts going in what assembly, with BYU 471. And then at your next team meeting, you're going to have one of the team members follow the process observation PDF format that is posted up on TCC. So one of your teammates will open that up, make sure that they kind of read it in advance, so the team leader can kind of assign who's going to do that. And then they will record the information on that while you're in your team meeting to just kind of see how your meetings are going, see what type of inefficiencies and what type of effective discussions you guys are having. So those will be the 2 homework assignments that you'll turn in. So the rest of the time, I'm going to kind of show you guys top down, show you why it's awesome, show you how it works, show you how to set it up, and then I will give you guys in-class time to ask questions and kind of figure out how you can get your stuff set up. So, if there's members from NTU, I do have Skype up, so I'm going to plug in here to Skype, and if they want to dial in, that's just fine, so they can ask questions. But we'll go ahead and get started here. Give me 1 sec to get my mic unraveled here. Okay, plug that in. Make sure I get the right pins in the right spot. Okay. Okay, so I'm logged in. All right, cool. If anyone calls in, all right, so I'm going to show you guys some cool stuff here. I already have the assembly created on my J drive. So if I go to, gotta remember where it's at. There we go. So, looks like I need to do an update. Just one sec here. There we go. Let me get my part all figured out here. I made some changes to it, and so when I was fooling around, I forgot to reset it. Okay. That one's the one causing
I'm on Skype, so we can check this guy.
There we go. Alright, this thing should be pretty much working. This part right here is causing some grief. I'm not sure why, but anyway, this is essentially the suspension assembly that I've got here on the picture on lab 4. And I've created this entire assembly using top-down assembly methods. As we talked about in class, if you have a small assembly with a couple of parts, it's probably not the best idea to do a top-down assembly, because if something needs to be changed, it's real easy to fix. But in the situation where you have lots of parts and something needs to be changed and you don't want to reconstrain things, top-down assembly is very advantageous. For example, say I've got this lower control arm here, and say that I made it the wrong length. And if I change that length, that would essentially break any constraints that would be right here in this section. You know, if this was connected to like a tire or a set of brakes. It also might, shift everything this way, and so it wouldn't be connected to this upright arm. So if I go into my tools and go to formula, I have a list of, make sure you're in product real quick here.
You mean the product structure?
Yeah.
The workbench?
In product, that's where all of your skeletal constraints should be. Okay. So if I go up there and go to my rename parameters, I've got a height, a length, a width, and a ball diameter that I have created. And if I change,
I'm in the product workbench, and I just went into formulas, rename parameters, and I see nothing. Do you know?
they should be there.
There you go. Okay, let me see. Okay. Okay. Cool.
Okay. So if you go to your, double click on your product, go tools, formula, and then come into this menu and go to rename parameters. There should be a list of parameters that I have already created. So I've got a height, a length, and a width. Each one of these will control how this part looks. So if I go to my width and I realize maybe I made it too short, I can make it 70 millimeters instead of 35. Press OK, and then I just need to do an update up here in my part tree. So this part, I think is part 3. No, let's do part 2. There we go. I think the auto update's turned off. Let me see real quick here if I can turn that on.
I hate it when
Automatic. There we go.
What did you just turn on? Like an auto update?
Auto update, yeah. It should let me update, but it's not letting me. There we go. Yeah, for some reason it's not updating automatically. It should, but we'll go through and update each one of these individually. That's fine.